Hello and welcome to the lecture on prospect theory. So what is prospect theory? Prospect theory is an alternative or an add-on in some ways to utility theory. So if you remember that utility theory is when we're trying to mathematically model how much people value certain decisions or actions or things. Prospect theory is a different mathematical function that you can use to actually model those preferences or those valuations that people give. Okay, and there's a number of characteristics that prospect theory has. One critical one is that there's the belief that the value function, whatever function we come up with, should be steeper for losses than gains. That we really don't like losses in comparison to gains. I would much rather gain $1 million than lose $1 million, for example. The other crucial one for prospect theory is this idea of status quo. So it's not always evaluating something from the 0 point. Evaluating one from where you are right now. What have you got right now, and then you're doing the comparison from that point. Okay. This is an interesting one. So this is one of the reasons why we got the false reference point when it comes to buying properties, is that people have this idea of the valuation of the house, and therefore when they're going to sell the house, they're not looking in terms of the actual market. They're looking in terms of what they believe, historically the house was worth. So if there's a housing crash like there was in 2008, you do see this problem that people are evaluating the house much higher than it should be, and they're starting from that point, and that leads to problems because then they have real difficulty in actually bringing the price down, and you get a stagnant market because people aren't actually selling the houses for a reasonable amount. Okay. So just to give you an example of prospect theory, I want you to just imagine this game. In this game, you've received $2,000, and you've got two options to choose for. First option is you receive another edit here. So to exemplify prospect theory, I'm going to give you a couple of games to just act as a mind exercise to understand why the utility function from prospect theory actually makes sense. So imagine you've been in a situation where you have, at the start of the situation, you receive $200. Okay, and then you're given this choice. You're given this choice. Do you want to receive another $100, or option 2, a coin will be flipped, a fair coin. There's no reason to suspect there's anything biased about this coin. And if it lands on heads, you receive an additional $200. If it lands on tails, you receive nothing. Okay, so that's game 1. Give you a moment to think about that. Alright, now let's look at game 2. Now this time you've received $400, and this time you've got to choose between giving back $100, which is option 1, or this time they'll be flipping a fair coin again, and if it lands on heads you must return $200, or if it lands on tails you get to keep all $400. So this second option, there's a risk that you might lose 200, but then there's a risk you don't get to lose anything. You don't have to give back anything. So I'll give you a moment to think about that as well. So most people prefer the certainty of option 1 in game 1. So when you're given $200, they like the idea that just get another $100 and not prepared to take the risk. Whereas people tend to gamble with option 2 in game 2. So They take the risk that they might lose 200, but they gamble so they can keep all 400. These preferences are actually irrational. You think, well, why are they irrational? Well, actually, you end up with the same results for both options in both games. Huh? I'll explain what I mean. Well, in game 1, you had 200 bucks. If you chose option 1, you get an extra 100 bucks, which is 300 bucks. So option 1 leads to 300 bucks in game 1. In game 2, you had 400 bucks minus 100 bucks for option 1, which is 300 bucks. So option 1 for game 1 is 300 bucks, and option 1 for game 2 is 300 bucks, effectively. And equivalently for option 2 as well. This time it's got the probabilistic aspects into it as well. So going on that mathematics, there should be absolutely no reason why you wouldn't choose the same option in both cases. But we do. And the reason we do is because we value losses worse than we value gains. Okay? All right. And I'll explain this a bit more mathematically in a second. The reason there was this issue with those two games was the status quo point in the first game was the 200 bucks. That's where you were starting from. And the status quo point in the second game was 400 bucks. Okay? Now, it's not unreasonable actually to actually say that that might not actually be the status quo. Okay? The actual status quo, you could argue, it was 300 bucks. Because you think about it, if you choose option A, you're guaranteed 300 bucks. So we could actually change around. So for some people, the status quo might be 300 bucks, not 200 bucks. Okay? So status quo's got some subjective nature to it. This is also critically important in terms of the actual individuals involved. So 300 bucks to Bill Gates is probably nothing. Okay? Whereas to a lot of individuals, 300 bucks is the difference between being able to pay rent that month or not being able to pay rent. So this status quo becomes even more complicated. I mean, you know, in terms of how much risk you're prepared to do, etc., on top of the actual initial status quo point and the decisions themselves. That's because we as human, we're complicated and we're also unique. And sometimes trying to mathematically represent us can be problematic. So I just want to show you graphically now the difference between the prospect theory and the usual utility theory. There's another things I'd like to point out here. So you've got the two different graphs. Now what you'll notice is on the utility theory, because effectively mathematically the two games are equivalent, because I said the outcomes are exactly the same in both cases, you're going to use the same graph in both cases. Okay, and what's the outcome of here? So if you do the gambling, you'll end up with 200 or 400, whereas if you do the just take the 300 extra 100 bucks or lose 100 bucks, you're going to end up with 300 bucks. And if you look at, so the average between 200 and 300 would be in the middle of that line, which is about here. And then if you then look at the 300 bucks, actually on the utility curve, you'll see it's slightly higher, which means that that you actually receive more utility by doing option 1, which is the utility theory estimate on this. Okay, this is assuming a risk-averse person, which makes sense. You know, the second one does involve some chance, and therefore you'd expect a risk-averse person to actually be risk-averse, therefore not taking the chance. Okay, let's have a look quickly at the second graph here, which is the prospect theory graph. Now, again, you got the status quo point here. I've assumed the status quo point is actually 200 bucks. Okay, so it's 200 bucks there, and you've got the gains, which is the game 1, and you've got the losses in game 2. Now, the game 2 status quo point is going to be 400 bucks because that's what you're thinking you've got in your pocket. Okay, so here we see in the game 1, again we've got exactly the same graph, sort of similar to what we just saw, but start at 0 and then 200 of the gains, and again the gains there, and then the gain of getting 100 is of a higher utility. Now when we look at the second one, we've got the status quo point of 400 bucks. We start here. We actually see here that the average between the 0 and the 200 bucks lost, we actually average them at that 100 bucks point, is higher than the utility of just taking that minus 100 bucks. So we would choose then the option 2. Okay, so let's look at the mathematics connected to the prospect theory then, as it relates to the mathematics for utility theory or utility functions. So traditionally, utility function is some function that is basically results in x to the alpha. I think I said x to the y in some previous lecture. Alpha doesn't necessarily mean it's a statistical test for some of you. I know that's it may always associate alpha with that. Alpha is just a arbitrary value here. It could be z, it could be L, M, whatever. It could be anything you like. It's just an algebraic representation. Now, prospect theory is a bit different. So, prospect theory, when you've got the above the 0 point, x above the 0 point, it's got x to the alpha again, like you do in utility theory. But when it's below it, because we're going to need to make this, we really don't like losses, we have to exacerbate it. So we put a kappa in there as well as the alpha. Okay, and that's how we get the negative, the values that way. Now notice that the x, by the way, when that's 0, is actually we're talking about the difference from the reference point, not necessarily the difference from the 0. So just some final thoughts on prospect theory. Trying to mathematically represent our evaluation of anything is problematic, and the idea that we follow simple formulas is problematic to say the least. So it's not perfect, but at least it gives us a starting point, especially if we're trying to understand different decision makers and trying to put some values on things. I mean, one of the difficulties we have as humans is that we just don't know how to value things. Okay, is my car worth more than my house? No. Okay, there you go. But there are circumstances where if my house was heavily mortgaged and my car was the only way it means I had to get to my job every day, and there was any other form of transportation, then it might flip the other way. Okay, but it does so. What prospect theory does do is just gives us some sort of like indication of how we can mathematically represent human decision making, and it does include some of that irrational behaviour that's status quo points that we've seen before.